is the greatest integer function? That's your topic. Okay? The greatest integer function is written as f of x equals, and it's kind of like a double bracket, x. All right? F of x equals double bracket x. The symbol, this double bracket, means the greatest integer. Okay, the greatest integer. And think about what is an integer. Those are all of your positive and negative values, whole values, so no decimals, okay? That is less than or equal to, okay, less than or equal to x. That may not make any sense till we go here, and then you'll see, okay? So in short, this means it will always round the value down to the nearest integer, okay, not up. It can't be rounding up because you want a value less than or equal to x. So that's why we round down if we have to round it all, okay? It's also frequently called a floor function. All right, so let's see. Given that our function is the greatest integer of x, find each value. Okay, so f of 7, the greatest integer less than or equal to x of 7 is just 7 because that's an integer. All right. Now the greatest integer of 2.3 is 2. Okay, so let's take a closer look at that. Integers here, -3, -2, -1, 0, 1, 2, 3. Those are all integers, okay? I can't have a decimal. So if I'm talking about 2.3, somewhere around there, okay, what is the greatest integer or the closest integer to that without going above it to 3? That would be 2, okay? And then what's our greatest integer? Ooh, this is negative now, so we'll have to talk about that, okay? We're going to round the value down to the nearest integer. When you round down with a negative, you're really going backwards. It's the same idea. Of course, we're going backwards. But that's going to mean it's this greatest integer is -5. Okay? So let me show you that on the number line. So we have -3, -2, -1. Let's go to -4, and I'll extend it a little bit to -5, okay? So -4.8 is here. I need the greatest integer that is less than or equal to the next one. So is -4 less than -4.8? No. So in other words, the only way I can go when I'm rounding is down. Otherwise, I'd be going to a greater than number. So that means -5 is its closest greatest integer, okay? I can't go above it. All right, so let's do some more. This time we have the greatest integer of x minus 5. So we're going to subtract 5 from whatever value they give us and then do the greatest integer. Okay, so this would be the greatest integer of 9 minus 5. Okay, which is the greatest integer of 4, and that is 4 because 4 is an integer, so we're good. All right, let's talk about b. This would be the greatest integer of 0.5 minus 5, which is the greatest integer function of negative 4.5. Okay, so is that answer negative 4 or negative 5? Well, if you look at our number line here, if I went to negative 4, that would be going up. Okay, we can't do that. We can only go down. So this greatest integer is negative 5. Excuse me, I didn't mean to have that decimal there. Obviously, we can have a decimal with an integer, so negative 5. All right, so let's do f of negative 8.1. That will be the greatest integer of negative 8.1 minus 5, which is the greatest integer of negative 13.1. Okay, and that's not 13. 13 would be greater. This has to be negative 14. Okay? All right, so let's graph this. Okay. I'm going to pick some specific values of x. If you don't understand the table, you will just have to literally memorize the graph, which is fine. It's not hard to memorize, okay? But I'm going to start with 0. Then I'm going to go to 0.25. Then I'm going to go to 0.5, 0.75, 1, 1.25, 1.5, 1.75, and 2. Okay? So I'm going up by a decimal. Hopefully you're seeing the pattern here. Okay? Going up by 0.25 each time. So the greatest integer of 0, 0 is an integer, so that's 0. The greatest integer of 0.25, well, the closest integer without going up is still going to be 0. Okay, the closest integer to a half without going up is still 0, and this is still 0. Okay? Now, at 1, the greatest integer is 1. That's an integer. Okay, and if I go on, the greatest integer of 1.25 without going above it has to be 1. This will be 1, that'll be 1, and then we're at 2. Okay, so what this looks like is what we call a step function. A step function where every single value in between 0 and 1 has to have the same value. Okay, so what that means is, let's graph it. How am I going to make some value where, okay, so the greatest integer of 0 is 0, but then a half is 0, 0.75 is 0, 0.99999 is still 0. Well, that's just a horizontal line. Okay, and then I'm going to go all the way to 1, but I can't include 1, because that's greatest integer is 1. Okay, then I'll go all the way to 2, but I can't include 2. Because if I got up to 2, its greatest integer would be 2. This is called a step function, where we're making steps, and they're following the same pattern the whole way. They're just making a step. Okay, so now I'm at 3. And think about if I did 3.5. That would still stay, oh, I did that wrong, didn't I? Oh no, we're good, sorry. So that would still stay at 3, okay? So that needs to be a flat line across. But once I hit 4, that's gonna step up to 4. All right, like I said, if that went way over your head and you don't get it, you just need to memorize the graph. It's not that hard. Close circle at 0, go across. Step up, close it, cross. Close, cross, close, across. Okay, and we're going to reverse it. So now I need open, closed. open, closed. Open, closed. Okay, open, closed. And for my last thing, I want to ask you, what is the problem, or what would happen here if I closed both sides? Why can't we do that? Other than the fact that the greatest integer of -4 would still be -4. It wouldn't be -5. Well, if you thought about the vertical line test, this would not be a function if I had two closed points, right? So that's why one of these has to stay open, okay? All right, so what is our domain? Well, we have a closed circle at every single value of x, or we have a line. Everything's either closed or part of a line, so that's all real numbers. Our range, though, that's a little tricky. Our range is only the integers, okay? There's no y value other than -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. No other values at all. So our range is going to be the integers, which is that double bar z. Or you can just write a z if you want. No big deal. Okay? That's it for page 1.